Hey everyone, can you see my slides now?
Yep.
Excellent. This part of my journey started at the end of last year when I saw this pop up on DBA Stack Exchange. It reads, I'm not a DBA, but we have almost 350 servers. How can we monitor all those? And I laughed pretty hard and I may have blacked out, but afterwards I realized that it's not really their fault because there's no training plan for being a DBA at scale, and it's quite different to being a normal DBA. But here's the answer. You just work 350 times harder, right? Well, not exactly. You see, there's a lot of responsibilities that we share between DBAs and DBAs at scale. It's anything that you can roll out to all of your servers without too much worry about the applications underneath. Things like backups and maintenance and jobs and patching. Security is a little different because you often don't have time to look into per database user permissions, but you sure can bludgeon a lot of other sysadmins, which generates a lot of paperwork. It's a lot of bludgeoning. Performance tuning is a little different though, because you won't have time to look at single servers and spending lots of time solving problems that won't benefit the entire fleet. And this is really the crux of the difference between a DBA and DBA at scale. DBAs at scale need to think of their entire server farm. And that is kind of a philosophy that we should follow. See, a DBA is a lot like a gardener in that they could focus on a couple of plants without any worries, but if a DBA at scale focuses on a couple of servers too much, well, the rest of the farm dies, and we don't want that. So, what would you do if you were a farmer or a DBA at scale to make things easier? Well, it starts with standardizing your servers so that when you solve one problem, you're solving 350 other problems. As my Twitter friend Lonnie says, you're steering towards known problems rather than unknown problems. But don't be like this person. Don't be the it depends person. That's no good at scale. At scale, you need to dig deep, pull out some righteousness, and say, is this better than having nothing or having 350 different things all at once? In most cases, doing anything to standardize is better than nothing, and so you should implement it. That's being a DBA at scale. Now, the people before you probably didn't do things like that, and this would be your first day on the job. You'd have 350 low memory false alarms because no one set max server memory. You have 350 different maintenance plans, and I bet that every day someone wonders why their application goes down at midnight, and it's because there's a tick box in a maintenance plan saying to rebuild an index, and you can't find it because it's an XML buried in MSDB. And 200 different backup locations. Don't ask about the other 150 backups. What's important is that everyone thinks things are being backed up. This is what happens when you don't standardize. Now you're probably thinking, this doesn't apply to me. So let's role play. Is max stop set on your servers properly? And don't worry, we're going to get into much more complicated examples. Max stop's easy. Sure, it's set properly on your servers. But hey, when did you last check all of your servers? A year ago? A month ago? How many new servers were built since then? Because if you have scripts that set this up, maybe you broke them a month ago and you didn't know. How many old servers were acquired since then? And these won't be the golden images that you've set up. They'll be garbage that you've acquired from accidental DBAs, and they won't have max stop set properly. Could any person or software have changed it? That's never happened before. Could someone have right-sized the VM and now there's a different number of CPUs and max stop is wrong? Which formula did you use from that first check when you started 2 years ago to the server that you checked yesterday, if you checked any at all? Is it the same formula? Could a SQL patch have reverted it? I haven't seen this happen to MaxStop, but it does happen to other settings. It's 2 a.m. Can you tell someone else how to validate it across your entire fleet? And if you didn't check today, how can you be sure? And what's your excuse when it turns out to be wrong? Because when you do check, I guarantee, oops, it will be wrong somewhere if you work at scale. Maybe even if you don't work at scale. Now, when I started with my first 100 servers, I knew exactly what I was going to do because I'm a PowerShell expert. These are my servers. I was going to consolidate a whole bunch of information. I was going to analyze it. and then I was going to standardize things. And that started off really well. The thing about working for a company with 100 database servers is soon enough, there's another 100 database servers for you to look after. In fact, you'll probably get them before you even finish standardizing the first 100, so now you need to go back to the beginning, work out everything you've done over the past year, and apply it again. But here's the thing about working for a company with 200 database servers. Sooner or later, there's another 100 database servers for you to look after, and another, and another. And then things get pretty bad, because that was the easy part. You're not even finished with your standardization. But then at 2 a.m., someone calls you and says, hey, the data center is down. Can you hand check those 500 servers for me? By the way, our monitoring system is dead. This is what happened to me. Now, I survived fine. Like I said, I'm a PowerShell expert, and I'd prepared all of those servers with a lot of standardization, and I had a lot of scripts and modules to help me out. But I'm pretty sure lots of other people would not come out of this so lucky. Let's get down to brass tacks. Your standards and the things you want from your servers, they're only good if you test them. Now, if you don't standardize your servers, if you don't have standards, if you don't actually test them every day, what are you even doing at work? Is it this? Because this is what you probably learned on your first day. You know, just fixing things over and over. Have you been doing the same thing every day for the past 10 years? I mean, not technically, but on a workflow level. That's the kind of realization I came to. Because I had standards, I had PowerShell, I had servers meeting my standards, but I needed a workflow, something that could really scale. I needed a way to standardize the PowerShell so my PowerShell could scale. And I needed to write my PowerShell faster and have it run faster because it takes a long time to run across a lot of servers. And it would be great if someone could validate it at 2 a.m. by pressing a button rather than me having to get up and do it. So this is the kind of workflow I came up with, and this is what I call operational validation. Now, so far we've spoken about best practices and standards and just problems happening, but really, I like to refer to these as expectations, because it's anything that someone thinks will be true that hasn't been tested. So next time someone wants something, or you read something, or you imagine your servers should be in some kind of state, instead of just expecting it, write a test in code to see whether it's true. And run it across all of your servers before you fix anything so that you know the test is actually working. Then, once the test has shown it fails, you standardize your servers to fix whatever problem you have, the tests pass, and these tests run every single day forever. When you set up a system like this, everything changes. When I ask you, is your max stop set properly on your servers? Well, this is a setting you own now. You're 100,000% accountable for it because you can prove it's true. You can reprove it on the spot. And even if you're wrong, if you miss something, if you're off sick, the tests will have your back and test for you. Yes, MaxStop is right. It's validated on every server today. This is the kind of answer that I want. So, we're going to be using Jenkins. Jenkins is used by a lot of programmers and a lot of people in DevOps because it's got a cool web interface to do stuff. There's a website to go to download it. But if you start using this seriously, then go to the web page here for the mailing list and sign up for their security list. What this will do is give you about a week's notification before any major security updates go out. Jenkins is like any other software. You have to keep it up to date. It can update itself. If you go into the UI and click things, you really want to be on top of this. Now, when you go to the web page, it's a bit hard to find what you have to download because it gives you Java files. But there's a little drop-down button here, and then you can go down to Windows and you'll get an executable installer, which we're all familiar with. How do you install it? Well, I've already got it installed in my demo environment, which is really simple. I've got a domain controller, a workstation that's running Jenkins and PowerShell, and a 3-node availability group. Installing it is easy, so I don't need to show you. Next, 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 and you're done. Well, you're kind of done. There's a little bit more because then it opens up a web browser. You need to put in a password. You just tell it to install the suggested plugins. You create yourself a user account, and then you've got a web page, and Jenkins is installed. That's not too hard, is it? Now, I've also done some other configuration on my demo. I've used the PowerShell Gallery, which you can access in PowerShell 5 and sometimes PowerShell 4 if you install an update, to install modules easily. So there's a couple of modules here at the top which I wrote, which I'm using. There's the DBA tools module, which I'm using for something. And I'm also using a newer version of PoshRS job than is on the gallery right now. There's a current version on GitHub, and that'll probably be pushed in the next couple days. It's because I submitted a whole bunch of bugs a week ago and got them fixed. So let's get started in Jenkins. Let me show you how to create a job and run some PowerShell in it. So I've switched over to my workstation, and here's my front page. This is running on localhost, although I've given it a pretty name, and there's not much going on. I'm going to create a new item here, and we're just going to call it demo. Now, most of the jobs you create will be a freestyle project. Just ignore everything else. Click OK. Save it. And build now tells it to run the job that we just created. If I go back to the front page, you'll see it's now showing my job, and if as I add jobs, it will create a big list. There's also a button here to quickly execute jobs as well. So going back into the job itself, what's happened? Well, it executed once here, and the green button here shows me what happened when I ran it, which was a success. By default, things will pass with success unless something bad happens. Of course, our demo hasn't actually done anything yet, so we need to add something. I'm going to add a build step, and this will be the main source of all of your PowerShell stuff. And then I'm going to break all of protocol by telling it to write host. Save it, build it, and there's our second run. And you can see it wrote out to the host and captured the output. What happens if we wanted to catch an error though? Like we wanted to fail the job? Well, go back into configure. This time, let me set the error action preference and write an error. Build again. And there we go. We've got a failure. And somewhere in here, it's got the error. There we go. It says hi. So we have a basic job. I mean, it's not very useful, but it is what it is. It's going to get better. Now, after we've created that simple job, we need to do some extra configuration to Jenkins. Yes, I've got another minute or so to talk about Jenkins. Jenkins Core is the core of Jenkins plus a whole bunch of plugins, but there's even more plugins available, and we're going to use a lot of them for the work that we're going to do. PowerShell, Active Directory, other things. Let me show you where you can go to install them. If I'm back on the main screen, here in Manage Jenkins, there's a Manage Plugins section, and it shows me all the updates for the plugins I've got installed. If I go into the Available section here, now I can do a couple searches and pick some plugins to install. So you'll install the plugins from my list, which I've already done. Also here in Manage Jenkins, there's a security system. By default, when you set up Jenkins, it's using its own internal security, but it's easy to link it up to Active Directory once you install that Active Directory plugin. It starts off here, you change it to Active Directory, you go down, you add your user, remembering it's case sensitive. This is my username on the domain. You give yourself access to everything because it's your Jenkins, and you save. Easy, easy. Oh, and just use this matrix-based authorization strategy because it gives you some flexibility for later. So, once you've done that, Jenkins is pretty much set up ready to go. So we can continue. What happened under the hood when we installed Jenkins though? Well, it's put a 32-bit Java runtime on the system, and I really recommend you install a 64-bit version. You edit this file here, and then restart the service. This is because, well, we'll get into that in a minute. It also created a service called Jenkins running as local system, which isn't great for a web application which occasionally has security issues. So in this case, I created a domain user. I just gave them control of the Jenkins directory, and I restarted the service. And that's it, it just works. Well, there's one more step, which is this really long command line here, which tells Windows that the service owner can restart the service, which is really useful for when Jenkins wants to apply patches to itself. Let's say you set this up at home or at work later on and you've got a bunch of problems. What are you going to look at? Well, remember, if you're running it under a service account, PS module path might be different. There's different paths for x86 and x64, so I usually work in x64, and so changing over that Java to use 64 is the easiest way to handle things. Some Microsoft modules don't work on x86 PowerShell. An install module installs separate copies of the PowerShell modules depending on which PowerShell architecture you're running. Don't forget to import any modules you need within that little Jenkins build step. You can't always rely on autoload. Autoload often works only because you've been tinkering around in PowerShell and it's got a kind of command history cache. Also, don't forget to grant monitoring access to your Jenkins service account, which I did on my first run through of the demo. In this case, I've given my Jenkins account access to my cluster boxes, but you could restrict permissions if you wanted to. Now, all we've done so far is have a job in Jenkins saying that something passed or failed, which isn't very useful. Jenkins wants better integration, and the way we do that is through passing it some XML. And in this case, I picked JUnit XML because it makes a lot of sense. JUnit XML has got a suite of tests, which is like a collection of tests. We've got these classes here, which are like just the name of the kind of test you're doing. So we're testing a Jojoba thing, and the name here is whatever server we're testing, or a computer, or a URL, something of that nature. It's a reference to the object that we're testing. By default, this first test up here will pass. The second one here will fail, and we can give it a message and a whole bunch of stacked data. Any data we want, really. It's useful for debugging, and you'll see that later. And we can also skip a test. Why would you skip a test? Well, let's say you were testing something like your availability groups, and you ran it against a SQL 2008 server. It doesn't really pass the test. It's more like you would skip it. But it's really up to you. Now, we're not actually going to do this, but in the background, I wrote a module called Jojoba, and it has a function here which can translate a PowerShell object into that JUnit XML. So I've set up a PowerShell virtual chapter collection of tests. I've got a specific test here, and I'm running it against the first node of my cluster. It passes, it writes it out to a XML file, and I'll show you how to pick that up in Jenkins later. And this is the kind of content it outputs. You don't need to worry about this. This is just how it works in the background. But we need to stop for a second and talk about something else, because we're talking about working at scale. Now, you're probably aware of PowerShell jobs, start, wait, receive, remove. You're probably aware of POSHRS job, and if you're not using it, just give up what you're doing with your own run spaces and use it, because it is really, really good. Why would you do it? Well, I ran this test earlier of a thread that sleeps for a second. I ran it 20 times in a row, which took 20 seconds. I used the built-in PowerShell jobs, which spun up 20 PowerShell processes and took 48 seconds to run, just on my slow VM here. Then I ran it through POSHRS job. It only took 5 seconds, well, 5.9. So there's real performance impacts from running POSHRS job over anything else. And people like me, and Bo Prox, of course, the person who created it, put a lot of work into making sure it runs properly, so you should probably use it. But using it isn't that easy. I mean, you have to remember syntax like this. You're starting the job, you're doing your stuff, you're throttling to a certain number of threads, you're waiting for it to finish, you're receiving. You don't want to be typing this every time you do something. So last year, I came up with a pretty cool idea, which was to create a kind of function that it's really a function template. Objects get passed in through here at the top. It automatically submits all of your POSHRS jobs to run. You write your code in here to do stuff, well, to test stuff. And then once the main thread finishes, it pulls back all of the data and returns it to you. And that was kind of a very primitive way of doing things, but it worked. But there are other problems with using PoshRSJob in this kind of way. And in this case, I really want to demo them to you. Besides, you're probably getting bored of just watching slides. So, here are my perils of multi-threading. I've got 10 servers. I'm going to generate a GUID for each one, and I'm going to randomly fail some and run it through PoshRSJob. So here are my server names. Everything's hunky-dory, and it all worked fine. Let's try again. Okay, this time we got some failures. Now, if I was running this against 350 servers, which servers failed? This isn't a very good way of doing things. You can work around it. You can add some more complex blocks that will store the name of the server in the job that's running and kind of output it in a certain way so you can pick it up and still have like weird errors and stuff showing around. But obviously that's not very cool. But wouldn't it be awesome if we could just combine that JUnit format with the PostJob format? So everything we run through PostJob, we get back in a really standard way. And I think that the mapping here works really well. And once you use it, you'll see how easy it makes things. So we have our modules. We have functions within the modules which do the tests. We pass on a name of some kind, like a server, an instance, a URL. We pass fail or skip the job, and we can output a whole bunch of data in it, but we have to keep track of all the errors that are happening. So this is my module Jojoba, and it's built on these three principles. Every test should automatically go parallel, using a kind of template like we saw before. Every test should return in a test format and handle all of that weird error handling for us. And it should also output in screen in a readable way, while also outputting to XML for Jenkins with all of the details. We can do this, and this is what it would look like. This is a kind of function template you would use based on Jojoba. All you do, put in the name of your function. Well, this is your function. You can give some useful aliases to whatever thing you're importing, like a computer name, server instance, URL. And here, you write all of your test logic. By default, everything will pass. Anything you output will get output into the JUnit format, but if you want to fail the job or skip something, you can also put messages in there. How would that look in real life? Well, we're going to see. So here I wrote something that's just going to ping some servers in parallel and output to Jenkins. So here's my ping name, well, function name. Here's my computer, and here is me doing the test and writing a fail out. So let's try this out. Here's my test ping. I'm going to save it into my module. Now we need to set this up in Jenkins to run. We can get rid of this. I'm going to create a new item. I think it's useful to name your job after the PowerShell you're going to be running underneath. It's a freestyle project. I'm going to add my build step of PowerShell. And I have a nice little way of wrapping everything. So I'm importing my module. I do this on everything that I do to capture errors and stuff. I'm going to get rid of this hi here. I'm going to use the DBA tools command that gets a list of registered servers from the first node of my cluster, and then I'm going to type it through to my ping function. If anything happens, let's catch it and put out some detail. Oh, and there's something missing here. This is how the PowerShell module within Jenkins works out whether something went seriously wrong. When our tests fail, we're going to turn that little green-red indicator to yellow to say, hey, there's something that needs attention. When our scripts fail, we're going to turn it red because that means we really need to investigate something. and that's registered through last exit code. Now, we need to do something to tell Jenkins to pick up the XML that we're outputting. So I add this XUnit report. Don't use the other ones, just XUnit. I output to a file called Jojoba. I'm going to give it a threshold of 0. If there's more than 0 failed tests, then we turn the indicator yellow, and we save, we build, and I really cross my fingers that it works. Although if it didn't, we would probably learn something. So it's running, and running, and running. You're probably thinking this isn't very highly parallel. Well, it is, just my laptop's a bit slow today. So here's the output that happened. So I outputted Jojoba stuff to XML that has the JUnit format, but I also output it here to screen because it's kind of useful to see in the output. Now, we have some pretty cool things here. Let's just build it one more time so that we get some more history. Here in the test results section, it shows us, it basically lets us drill down into what happened, showing us what happened on each server. If any failures happened, it would highlight them. But we're going to get a really cool report out of this too, once we've got our history. Any day now. Okay, so we've done our 2 tests. They both had 3 passes, so we get a cool test result trend here. But one of these plugins we installed was a test result analyzer, which also gives you a graphical way of showing, hey, which servers failed on which builds. This is starting to look pretty useful, right? Well, I sure hope so, because that's the rest of my presentation. Now, that was pretty simple. Well, I mean, it will appear simple as we progress, but we need to talk about other things to do with coding at scale. Don't use WMI. This is a little network trace I caught earlier of what happens when you just query a simple class, 72 packets. That's like a really long amount of scroll there. Instead, I have a module called sim. Now, in PowerShell 3 and above, you already get some functions, well, commandlets, called new sim session and get sim instance. But it doesn't work to Windows Server 2003, so Mike Robbins created a new function that can replace new sim session, and I've built on top of that and called it new sim session down. And what this does is it also caches any sim session object that gets created to another server. What does that mean? Well, first we connect to a server, which is creating a session, and then we run a query that looks exactly like what happens in WMI, and the output is almost exactly the same. We also give it a timeout, because WMI will almost always kill anything running across 400 servers, because when WMI doesn't return, your tests never return. By using sim, we make sure that we're going to get a proper timeout. And it results in a lot less packets. In fact, I could run 100 of these, and it would just be 12 packets plus 100 by 9 packets. I mean, it's really, really efficient. I've got some other cool things in my sim module too. You can query the registry over sim, and it's quite fast. Probably 20% faster than what I can do in raw.NET, and twice as fast as some other modules that do registry queries. And it will time out if you want it to. So this is pretty cool. In fact, we're going to be using this later. Let's talk about Invoke SQL CMD, because at scale, you should never use Invoke SQL CMD. Why? Well, I'm just going to love showing you what's wrong with it. Let's open up Invoke SQL CMD. Here's my first test. I'm just going to run it 100 times a simple query against my server. Now I'm going to put it into a run space and run it 100 times in parallel. Do you see all of those errors? Invoke SQL CMD is not designed to run in parallel, so don't use it. But also, Invoke SQL CMD takes variables, which a lot of people think are like parameters. They're not. They're prone to SQL injection, like this, where I just pulled the first database name from sys.databases in an otherwise innocuous query. What's the alternative? Well, I wrote a module called DBData. It runs in run spaces. It doesn't have those injection problems. We can get info messages. We can do retries on timeouts and deadlocks, CRUD, upserts, bulk inserts. We can use transactions through PowerShell, and we can quickly get SMO and WMI properties. Let me show you some examples. So, I'm going to run it 100 times in a run space, and I don't have any errors. I pass parameters in a very similar way, but I'm using a hash table, and then I use the name of the keys from my hash table here as parameters, and I pass the hash table into parameters. You'll also see I follow a style here. We create a connection, we create a command for the connection, and then we get data. It's not prone to injection. How would we get output? Well, you don't just get output anywhere. You can dump it into a special array variable with all of the detail about states and classes and everything else. Hey, what if we wanted to do retries? Well, you can do that too. Here I've got a query that will wait 10 seconds, but it times out after 1. And you'll see DBData catching the timeouts, doing a small sleep, and then trying again, and then eventually failing when it doesn't succeed. DBData is pretty useful. Take a look. And with that, we're ready. We're finally ready to test stuff, which should be more fun than this. But I want you to think about your workflow. I want this to be like your day tomorrow and what you would do tomorrow. When something happens, you ask, what expectation was missed here? You write a test for it, you add it to Jenkins, you run it across your fleet, and you make sure that the test fails. Often when you do this, you'll find that your test maybe didn't work on a couple servers, and you have to tweak your test. And then once everything is confirmed failing, then fix or standardize wherever possible, and then confirm the test passes. Now, in Jenkins, there's a step which can be used to schedule these jobs to run every day, and I'll show you that a bit later. This is the workflow. Now, it's 9 a.m. tomorrow. You walk into the door, and an application on an availability group node went down this morning. What happened? Well, it wasn't in the availability group. That's probably a mistake. Databases on availability group nodes should probably be highly available. There may be exceptions, but if this suits your environment, maybe you want to test it. So let's see what a test like that would look like. I'm gonna save this. Maybe I should just drag them into. That looks like it could work. Okay, so the base of the test here is I'm connecting to SMO. And if you've worked with availability groups through SMO, you will know to do this before you touch availability groups. The reason for that is that this will be false on SQL 2008, whereas this will result in an error. So, if availability groups aren't even enabled, then let's skip the test. Otherwise, we're checking non-system databases, we're checking if it's listing an availability group name, and if it's not in there, then we fail. So, let's add this to Jenkins and see what happens. Once I copy and paste the name properly. You can also base it on previous jobs. So let's base it on that ping job so I don't have to re-enter all of the detail. Now remember I said these things could be scheduled? That happens here in build triggers under build periodically. And you can enter some stuff here in a cron format that tells it when and how often that job will run. We're not going to do that for this though. So I'm getting my server names, I'm putting them into my test. Everything else is same old. Now I really cross my fingers This is our workflow. What I find interesting is that before the session started, I was running all of these and they were really fast, but now my VMs are slow.
Happens to me all the time. It's the video with the GoToWebinar.
Yeah, that could actually be it. Okay, so we've got a failure, which is good. What happened? Well, looking at the console output, we can see some of my databases aren't in an availability group. That's a bit strange. I'm not going to fix this one, and that's because I've got another test to do later that depends on this kind of behavior. But you can see here that the failed tests show me a whole bunch of detail about what is actually wrong. So we have a test to confirm whether our databases on an availability group node are in an availability group. That sounds reasonable. But the next thing that happens is we see a message come in about an I/O error, and we start wondering, do we have any suspect pages on our servers? This is actually two parts because you have a suspect pages table in MSDB that you should check every day, which records the I/O errors on pages. But your databases need to be configured to actually store checksums as well. So we're going to do a test for that. What does it look like inside? Well, it's all of our boilerplate, which we can ignore. And down here, we've got our actual test. We're connecting to the database using DBData. We're checking suspect pages, and if there's any output, we'll write it to Jenkins, and we'll also fail the test. After that, though, we'll continue checking to see, hey, do our databases have a page verify checksum? And if you're still running SQL 2005, we'll check TempDB as well, because that doesn't go that high. It only goes to torn page detection. Let's create a Jenkins test for this. Basing it on one of my existing jobs. And let's build it and see what happens. This one I may be able to fix. Let's see what it says. Okay, we had a failure. It was only on one of the nodes. We've got suspect pages, and we've also got a database which isn't set to checksum. And here's the output from our suspect pages table, which I retrieved using DBData. So let's fix this time and see whether the test passes. We don't care about what suspect pages we have. Let's just delete them. And let's set on page verify and run the test again. This would be your daily workflow. Something happens, you create some code to test it, you confirm the test fails across your fleet, and then you fix the problem and make sure things turn green, which hopefully they will. And it's green, look at that. And here's our test results trend. And if we dig into our test results analyzer, we see, hey, this server used to fail, it doesn't fail anymore. If we click that, we can even see what failed back in time. That's pretty cool. But we're just getting started. That was the easy part. These are going to get harder. Hey, at lunchtime, someone thought it would be a good idea to move a database to a new availability group, and now reports are causing all kinds of blocking and the application's going slow. Do you know what happened here? Well, we have an expectation when a database is on an availability group and you're running enterprise that your availability groups are configured to offload reads. Let's test that. What would that test look like? How would you test it? This is one of the benefits of standardization. We fix the problem once and it fixes it everywhere. So again, I'm checking whether we've got availability groups on the server. I'm going through each availability group, constructing the listener name, getting the first database from the list, connecting it with application intent read-write and read-only, comparing the result, and then writing a fail if something is wrong. Let's try this out. The more times we go through this, the faster it becomes. Oops. I forgot to base it on an existing job. Let's try this again. These tests are going to get even more interesting. I think there's 3 more. Maybe I'll skip some. $9.51, okay. Maybe I will skip some because we won't have time. Here's our test result. The availability group on our availability groups don't have a proper read-only redirect working. I can fix this. In fact, I've got it in my demo script by creating the roles, URLs and lists, but we'll just assume that that's all good for time reasons. So after this, there's something weird about my demos. You probably haven't noticed, but there's a misconfiguration between my servers. Here's my first node, here's my second node, here's my third node, and oh no, why are they running on different versions? They're in an availability group. These should all be the same version. That sounds like an interesting test. What would that look like? Well, for an availability group, it's quite simple because you can just connect using SMO, get a list of the replicas, and test each version against each other version. It's not too difficult. But you probably don't just have availability groups, you probably have clusters, and this is where it gets even more difficult. The way that I worked out to do this, seeing as some cluster nodes will be offline and you can't query their version, let's look at the SQL Server service. Let's work out the executable it points to. Let's get the file version from that across all the nodes and compare it. As you can see, it gets quite messy. Thing is, you only have to do this once, and after that, you're set for life. I won't set up a job to show this, but it does work. Now, 2 p.m. Hey, let's talk about patching. You're about to apply a CU. Have you ever seen this warning though? Incompletely installed. What is that? This happens at scale all the time. When you have 400 patches going out to servers, if any of those servers reboot during patching, often the patch gets marked as success by Windows Server Update Services, but it's actually broken. How can you detect this? Well, this is some secret sauce because I don't think anyone else in the world does it, and it sure as hell isn't supported by Microsoft, but this is how I do it. What I think it checks is in the registry, under the SQL Server key, there are other keys, and some of these will have a configuration state and an upgrading complete state. And certain figures in here will determine whether that patching succeeded or didn't succeed or failed partway through. We're going to query it over SIM using my SIM module. We get all of the keys from here. We go one more level deep, and then we get any of those keys which match these two. And then I check the various values and write fails or success. This one's kind of interesting, so maybe I will actually create a test for it, just to show you that it works. This is way better than just fixing problems over and over and over again. Let's build this. Let's see what happens. The output from this will be quite interesting. There are other ways to pick this up. You can also pass the setup bootstrap log files for patches, which is also really useful to work out what exactly went on instead of just listing a bunch of registry keys. Here's the test result. I purposely failed this patch earlier by restarting my VM during the middle of patching, and you can see it's broken. What happens when patches get into this kind of weird state? I don't know. I don't think you'd want to log a call with Microsoft when your server's in this kind of state. I would probably go to work now and find out, do any of my servers have this kind of setting? You are going to be surprised. But hey, it's 2 a.m. and you're going to experience the same thing that I experienced. Look, the SAN restarted and all the disks on every server, including C drive, may have disappeared for a few seconds. What does that do to SQL Server? No one knows. This isn't documented anywhere, and you can't just reboot all of the servers either. 400 servers, they're running some critical stuff. But what's the expectation here? Well, I set two very basic ones, that you can connect to each instance, and every database should be accessible, but there's a bit more secret sauce here as well. So, going to my demo, here is the final test. What does it do? Well, the secret sauce here is actually pretty cool. I'm connecting to the server, to master, pulling out a list of databases in state. Now, if any databases aren't online, that's probably a problem. Now, I start cycling through the databases. If I can't use a database, then that's a fail. But after that, let's have a look at the tables in the database, because sometimes you can use a database, but you can't access the data. I mean, literally, the system table metadata cannot be accessed when this weird thing happens. But also, it might not throw an error. It will just close the connection straight away. So let's pick that up as well. And that's still not enough. In some cases, those first two tests will fail, and the log cannot be read, so nobody can write to the database. And again, it may just close the connection. So now we've got a whole bunch of different tests to find out this weird scenario. Do I have this problem in my demo environment? You might be surprised. Let's create a test to find out. These are the kind of lessons you learn at scale, because something weird is always happening. And that's why it's good to store that information in these tests, because that's quite a complex thing to describe to someone and have them run at 2 o'clock in the morning across all of your servers. Yes, one of my servers does have this problem because I disconnected the disk earlier. And as you can see, all of the tests passed, as in I could use the database, I could select from sys.tables, but when I got down to querying the last result out of the log file, the connection was cancelled on me, and this is a clear indicator that something is wrong. So what do we have here? Well, here was my initial demo where I had an error, where I caused an error in the script to happen. All these other ones are proper tests, wrapped in jojoba, yellow for saying that some things need to be addressed, and green to say everything is a-okay. And we're almost done. Well, that was the screen when the disaster happened. Moving on. Now, let's say you want to do some of your own tests. Well, you probably have tons of things you can test if you just think about your expectations. But if you have nothing, test Kerberos. Connect to servers, see whether the DM exec connections authorization scheme is what you expected. And test it on your listeners too, because it's often not set properly there with SPNs. Check your reverse DNS, Make sure your system traces are running, because if one of your disks runs out of space, the trace will stop running and you lose a bunch of useful diagnostic information. Check for pending reboots, because pending reboots can cause SQL CLR to fail. There's also some tests built into DBA tools, though you have to be careful because they're not all written for scale. Many of them will work. Also, Sentry 1 posts a list of conditions it checks in its software, and I'm sure they don't mind if you just take a look and use it for inspiration. Now, what happens after you do this for a while? Well, this is a more comprehensive testing setup where I have over 60 jobs running 20,000 tests in the morning within an hour across 400 servers. You can see there's a lot of work to do. There's also a lot of green, and that's really hard-earned green. When another 100 servers gets added in, I know exactly what I have to go and fix up. Now you're probably thinking, what if I just have one server? How does this apply to me? Well, this is probably what you think your server looks like, and this is probably what it's like inside. Look, your server will have problems too, and you should test it. And often, one server becomes two servers, which becomes more servers. There is a downside to the operational validation cult, though. Once you start validating everything, you discover that everything you thought was standard or working in your environment is wrong. Everything your coworkers say is wrong. Everything your bosses say is wrong. Everything other teams say is wrong because they've never validated it. Or they did it by hand years ago, or they used little PS1 scripts to do it instead of putting it all into a module, all into Jenkins, and scheduling it and finding out the truth, whether they're right or not. The only advice I can give you for working through that frustration is don't bludgeon them to death, because it's a lot of paperwork. And that's the end of my presentation. I registered a domain name, operationalvalidation.com. I pointed it to my blog, and I'll be posting updates there. So I think I'm ready for any questions now, if anyone has any.
Alrighty, thank you very much, Cody. That was an awesome session. As a Jenkins user myself, I actually learned quite a bit of stuff there, so thank you. We've got one question. When creating the job in Jenkins, where you put the PowerShell script, one server name is hard-coded in the PS script. What is telling it to run across two or more multiple servers?
Oh, so what this is, this gets a list of servers from a CMS. So if I paste that into here, these are just normal, this is a normal registered server list here in CMS, and it's just a DBA tools command, so it pulls out those three strings, and then that gets passed to the test.
Nice, cool, thank you. We've got a little bit more time. If we've got about 4 minutes to go, if anyone else has any more questions.
Okay. While we're waiting for questions, there is something else cool. You'll notice in a lot of the scripts I did, I put a little pipeline operator up here at the beginning. Why do I have that? Well, in this case, I'm only passing in the server name itself. But what would happen if I had a more complete inventory system which had a whole bunch of other data with it? So let's put a computer name, let's put a department, infernal affairs, and location, hell. And then I pipe this into test PSVC database access check. And I just need to refresh. Now, the way
Cool,
that
we've got a couple more questions.
the way that the Jojoba module is structured, you can still pipeline in a whole bunch of other information. The input object, which we've aliased to computer name, is really important for handling all of the internals, but you still have this other information. Now, when this fails and it shows in Jenkins, this will be put inside that data section, so I know C1N1, if I have 400 servers, I may not know where it is, but my inventory system has recorded all of this information, and if I can pull it out in PowerShell and pipe it into my tests, that all becomes available at my fingertips. So that's pretty cool. Okay, questions?
Nice one. Question here, is it easy to include SSIS validation using Jenkins and PowerShell? integration services,
I've
or
never tried.
SSIS validation?
I've never tried because I don't use SSIS for operation stuff, and I'm only on the operations side. So all of this is focused on operations. I really don't know.
No worries. Last question. Have you tried using Invoke SQL Command 2 to scale?
I have. The thing is that Invoke SQL Command 2 really just lets you run a simple command, whereas DBData lets you do so much more. It outputs the data tables and, like I said, the transaction handling. I also use it to maintain my inventory system to write to the databases. And you can also hook into Jojoba and write the test results out to a database using DBData. So you can use it if you're just doing simple stuff and that's what you're comfortable with. Go ahead. But if you do a lot of SQL work in PowerShell, I think DBData is probably the best